Hey everyone, so our next lesson is on rotations. A rotation is when you turn a figure about a point. So that's the center of, or the point of rotation, which typically for us it's going to be the origin, which is 0, 0. So we'll always be rotating around the origin unless otherwise stated. So there are a couple things you want to ask yourself. The first thing is, how can we turn objects? Like in what direction? There's two directions we can turn objects. There's clockwise, which I always abbreviate as CW. And then there's counterclockwise, which I always abbreviate as CCW. So clockwise goes like a clock that way. Counterclockwise goes that way, against the clock. The two D's of rotations are the two things that you need to know in order to do a rotation, and it's the degree, so how many degrees we're rotating it. We do increments of 90, so 90, 180, 270. And then also you need to know which direction you're rotating it, clockwise or counterclockwise. Most kids use the coordinate rules for rotations, so let's talk a little bit about the coordinate rules. It looks like a lot, but a lot of them end up being the same. So first let's do 90. So let's do 90 clockwise. So a 90 clockwise rotation, if I was starting here, would just be like one quadrant. Every quadrant is 90 degrees. There are 4 quadrants. So each time you move a quadrant, that's another 90 degrees. So that's what 90 clockwise looks like. When you're doing rotations that are 90 degrees for the coordinate rule, you automatically are going to switch X and Y. And then one of their signs is changed. And how I remember which one of them is changed is, see how in this little picture that I just drew, 90 clockwise moves to the right. So therefore the one that's on the right changes its sign. That's how I remember it. 90 counterclockwise would go the other direction. And again, you're changing X and Y, you're swapping them. But this time, since counterclockwise moves to the left, you're going to change the sign of the one on the left. Okay, let's take a look at 180. So 180 clockwise, if I'm starting here, 2 quadrants, that's 180 degrees. That's where I would end up. Let's look at counterclockwise. Do you notice we end up in the same spot? We end up down here in both of them. So that means that with 180 degrees, whether you rotate it clockwise or counterclockwise, it's the same thing. These are the same. So it's the same rule. The rule is negative X, negative Y. So you just are changing both of their signs. You're not moving them around. And it doesn't matter which direction, it's the same both ways. Let's look at 270 clockwise. So 270 clockwise, I'm starting here. This is 90, 180, 270. I would end up here. Do we notice where we end up? On that left side of the x-axis. Do you notice that this 90 counterclockwise, you end up in the same spot? So 90 counterclockwise and 270 clockwise have the same rule. So if I'm trying to think of what the rule is for 270 clockwise, I know it's the same as 90 counterclockwise. So it's negative y x. Then let's talk about 270 counterclockwise. So this is 90, 180, 270. Look where I end up. I end up on the right side of the x-axis, which is the same as 90 clockwise. So that means 270 counterclockwise and 90 clockwise are the same. So it's y negative x. So notice a lot of the rules are sort of the same. You just have to remember which ones are the same. So like the 180 ones are the same. 90 counterclockwise and 270 clockwise are the same. And then 90 clockwise and 270 counterclockwise. 360 we don't really ever do. But whether you're going counterclockwise or clockwise, if you're going 360, you're going to end up right where you began. So that would be clockwise or counterclockwise. So that's just XY. So I don't ever ask you to rotate 360. I just like to mention it so you know what would happen. Okay. Let's do a couple examples. So this first one, what are the coordinates of 3, -2 under a 90 counterclockwise rotation about the origin? So first, 90 counterclockwise. Remember that for 90, you're switching it to YX, and then counterclockwise moves to the left, so we're changing the sign of the one on the left. So that's the rule for 90 counterclockwise. So here's X and Y. So we're going to swap them and change the sign of the Y. So that -2 is going to become a +2, and then the 3 stays positive. So that would be the coordinates of that point after a 90-degree counterclockwise rotation. Next, coordinates of -5, 4 under a 180 clockwise rotation. So 180 is -x, -y. So if this is X and Y, they're not switching spots this time. They're just both switching signs. So it's going to be 5, -4. Number 3, 270 counterclockwise. So 270 counterclockwise is the same as 90 clockwise, which remember 90 clockwise, we're switching X and Y. 90 clockwise moves to the right, so we change the sign of the one on the right. You could just look at the chart too. I'm just trying to teach you like little ways to remember it just in case we do have to be back in school when you're being assessed on this. Because you'll have to know these rules. Okay, so Y -X is 270 counterclockwise. So if this is X and this is Y, the Y comes first and it doesn't change. And then comes the Y and it does change. So that turns into a +1 rather. So -3, 1. So that's just some practice with using the rule. Let's do a few actual examples. So number 4, we're given that we want to rotate triangle JQH 180 degrees, and it doesn't give a direction. That's because it's the same both ways, so it's fine. So let's first write out the points. So J is at 1, 2, 3, 4, -5, -3. Q is at 0, -1. H is at -3, -5. I'll use a different color to do the new one. So J prime, I'm going to take -5, -3 and change both of their signs. So it's going to be 5, 3. Q prime, change both of their signs. Well, 0, you can't change the sign of 0, but there you go. 0, 1. And then -3, -5. Whoops, forgot to close that. -3, -5 would be 3, 5. And then you just plot them. So 5, 3 would be here. Here's J prime. 0, 1 is Q prime. 3, 5 is H prime. So notice everything moved over to quadrants, and then you would connect. So there's example 4. Notice everything was moved 2 quadrants over. Okay, next one, number 5, is 90 clockwise. So 90 clockwise, remember anytime it's 90, you swap X and Y. Clockwise moves to the right, so we're changing the sign of the one on the right. Okay, again, we're going to need all these ordered pairs. So B is -5, 1. F is -1, 3. H, -1, -2. M, -4, -2. So now I'm going to apply the rule, Y -X. So basically all of the Y's are going to come first and they're not changing the sign. So B prime is going to be 1, and then the X comes and we change the sign of the X. So 1, 5. F prime is going to be 3, 1. H prime is going to be -2, 1. And M prime, -2, 4. Once you get your points, then just plot them. So B prime is 1, 5. So that's going to be here. So you kind of have to picture for these that everything is moving over 1 quadrant to the right. So like this whole thing is going to shift over here. Okay, so B prime was 1, 5. So that's right here. F prime is 3, 1. H prime is -2, 1. and M prime is negative 2, 4. And then we can connect. Notice that everything is the same size and shape as the original. So the two shapes, the pre-image and the image, are congruent because these are congruence transformations. Okay, a couple more. Number 6, we have 270 clockwise, which is the same as 90 counterclockwise. So that's going to be negative yx. And so we need our points. So U is at negative 4, negative 5. H is at negative 2, negative 3. F is at negative 1, negative 5. Okay, so now we're going to apply that rule, negative yx. So the y's are all going to come first, and they're going to change their sign. So these are all the y's. Those are going to come first, and their sign is being changed. So u prime is going to be 5, but then x doesn't change its sign, negative 4. H prime is going to be 3, negative 2. F prime is going to be 5, negative 1. And then you plot them. So 5, negative 4 would be here. So that's a u prime. H prime is 3, negative 2. F prime is 5, negative 1. There also is a way to do these without the coordinate rule by like turning the paper. But if you're interested, let me know and I can meet with you virtually and show you. So there's that one. Okay, and then the last one is not last one. Last one we're doing it and not identifying the rotation is number 7. The 180 is negative x, negative y. This one already actually gave us the points. So V is 2, 0. S is 1, 3. G is 5, 0. And so now for our new points, I need to just change both of their signs. So V prime is negative 2, 0. S prime is negative 1, negative 3. G prime is negative 5, 0. I'm going to plot them in a different color, even though I know I just wrote those out in red. But okay, negative 2, 0. Here's V prime. Negative 1, negative 3. S prime. And negative 5, 0 is G prime. And there's that. Notice everything moved over 2 quadrants. Okay, so that's how you do a rotation. Now identifying a rotation. So first of all, this is a rotation because you can see everything's turned. It's not in the same orientation. Like R is not in the top anymore. It's on the bottom. So you can kind of tell that it was turned, the figure. It's kind of hard to show this electronically, but basically you could also look at a pair of points and look at their coordinates and figure out which rule was used. But I like to just count how many quadrants each point moved. So R and R prime, notice it just went 1 quadrant, and same with the others, and it went 1 to the right. So we could say this is a 90-degree clockwise rotation, which remember is the same as saying this way, which would be 270 counterclockwise. So either one of those would be correct. And then the last one, notice everything moved 2 quadrants. So from here to here, all of them. And so that's 180. And you can say clockwise if you want, or you can say counterclockwise, or you can just say 180 if it's 180 because it's the same both directions. And so that's it. That's how you do rotations. Please let me know if you have any questions. All right. Have a great day.